Next, we're going to talk about something called the chain rule. And the chain rule is applied to functions called composite functions. They're basically a function that is applied to another function. Okay, so these are known as composite functions, and we're going to go through the precise definition and a few examples just to make sure we understand what they are, and then we'll practice taking derivatives with them. Okay, so let's first define what a composite function is. So let's say we have real valued functions, we'll just call them f and g. The composite function denoted this g little o of f, it's pronounced g of f, is defined by the following. So the actual name of the function is this g of f, and now what it's being applied to is x. So before we would have something like f of x, but instead of f, the name is this g of f. That's why there's brackets around it. Okay, now what is this equal to? This is equal to, first what we would do is apply f to some input x, and then whatever that answer is, we would apply g to it. So how the letters read from left to right, you have the first function that is applied to x is whatever is most right, okay? So the f here. And then g is applied to f. So the output of f of x is the input of g of x. And here's just a little diagram to show what I mean. So say we have, real valued functions. This would be the domain of f, okay? This would be the codomain, okay, specifically the range of f. This would be the domain of g, and then the codomain or range of g. So say we have an x, I put this x through my f, it spits out f of x, and then f of x is a thing that goes into my g, and it spits this out. Okay, and sometimes in these drawings what you'll do is you'll see the composite function, this g of f, it starts here, this is its domain, okay, and its range would be in here. Okay, so let's do a few examples. So let's first say that we have f of x is equal to 2x minus 1, and say we have g of x is equal to the square root of 3x plus 5. And we want to find g of f when the x we want is 4. Okay, so if you don't like this notation, it just means this. So the first thing that we need is this f of 4. Well, what does f of 4 mean? Well, f of 4 means that we would have our 2x minus 1, but the x I'm interested in is 4. Okay, so this is just going to be equal to 8 minus 1. This is just 7. Now, what is my g? My g is 3 times whatever I'm inputting plus 5, and then we take the square root of that. So the input in my case is whatever this f of 4 answer is, and that is 7. Okay, so we're going to have 3 times 7 plus 5 in the square root. So that's going to be 21 plus 5 is the square root of 26. Now let's do if we have f of g where x is 4. Okay, so first thing that we're going to need is this g when we take x is equal to 4. Well, again, what was g? So that was 3 times whatever the x was plus 5. And then we took the square root of that. Well, the x that I want in this case is 4. Okay, so this is just going to be 3 times 4 is 12 plus 5. So this is the square root of 17. And now I'm going to apply f to this. So f of g of 4. Well, what was my f again? My f was 2 times whatever that input was minus 1. And my input would be the square root of 17. So this I can't really simplify, so I just leave it as 2 square root of 17 minus 1. And then there's my answer. Now what I'm going to do is I just want to have g of f with respect to x. So I'm not picking a specific value for x now. I want to leave it in general, and I want g of f and f of g. So let's start off with this first one, g of f here. So what's my f? My f is 2x minus 1. So if I apply g to this, so g of f of x, what's my g again? My g is 3 times my input plus 5, and then we take the square root of all of that. Now, my input in this case is this f of x. Okay, so 2x minus 1. So if I expand that, we're going to get 6x minus 3 plus 5, and then we take the square root of all of that. Okay, so we have 6x minus 3 plus 5 is plus 2, square root. So this is what g of f of x is equal to. Okay, now we're going to do it for f of g. So this is my g here, the square root of 3x plus 5. And now this is going to be my input for f. And what was f? Well, we're going to have 2 times whatever is going into the function, minus 1. What's going into the function? Well, that's the square root of 3x plus 5. And again, this we can't really simplify it, so we can leave it as 2 square root of 3x plus 5 minus 1. All right, let's do another one just to make sure we understand. Okay, so we're going to take f of g and g of f. So first, let's start off with g of f of x. Now, what does this mean? Well, first I want to take whatever f of x is, and then I'm going to apply g to it. So my g is 4x plus 1, but instead of putting in an x, I want to input my f of x. Okay, so we're going to have 4 times what we want, okay, our f of x. So that's 2x squared plus 5x, and then we still have this plus 1 here. Okay, so if we expand that, I'm going to get 8x squared plus 20x plus 1. Now we're going to do it the other way. We're going to apply our f to g of x as our input. Now, g of x is just 4x plus 1. And what was our f? Our f was 2 times the input, and then we square that, plus 5 times the input. And what's our input? Well, it's going to be this g here. So 4x plus 1, 4x plus 1. Okay, and now I have to expand this. So we're going to have 2, and then I have to do FOIL. So 4x times 4x is 16x squared, plus 4x is 8x plus 1. And then I have plus 20x plus 5. And I still need to distribute my 2 into the 16x squared plus 8x plus 1. So I'm going to have 16 times 2. This is going to be 32x squared plus 16x plus 2. And then we still have this plus 20x plus 5. So we're going to get 32x squared plus 16 plus 20. So that's plus 36x. And then plus 2 plus 5, that's just plus 7. Okay, so hopefully that gives you a little bit better idea of what a composite function is. Now we're going to take the derivative of them. So let's say we have this composite function, h of x is equal to f of g of x. Now, if I want to take the derivative, we start from the outside and work our way in. It's like sitting at a fancy table. You have all these utensils, you start from the outside and you work your way in. So we're going to take the derivative of the outer function, so the f first, okay, and then we leave whatever's inside, but then we say times the derivative of the inside, so times g prime of x. Now, if you don't like this notation, sometimes in books what they do is they'll say, okay, so we can think about y is equal to f of u, where u is some function. So if I have y is equal to f of u, in other words, fg of x, and I want to differentiate, I'm differentiating with respect to x, so dy dx is equal to the derivative of the outer part, so dy with respect to u, and then du with respect to x. Okay, so if you prefer this way, that is totally fine. So let's look at this first example. Now, in this situation, we have something to the square root. So the outer part of the function would be considered the something of the root. So we can think about it if you want to put it into this f of u terms. It's like u to the power of 1/2. And then we would have to then differentiate this 3x squared minus 5x. Okay, so typically how I just write this is I always ignore the stuff in the brackets, and then we're doing the power rule. So we bring down the exponent. Okay, I'm ignoring the 3x squared minus 5x for now. Subtract 1 from the exponent. And now I worry about the derivative, the d dx of the inside, the 3x squared minus 5x. Okay, so what do I have here? So I have 1/2 times 3x squared minus 5x to the power of negative 1/2. And then this is times the derivative of 3x squared minus 5x. This is 6x minus 5. Okay? Now, what is this equivalent to? This is equivalent to, this is on the numerator, but this is to the negative 1/2. So this is actually on the denominator. And then this 2 is also on the denominator. So it's equivalent to write 6x minus 5 all divided by 2 times the square root, or you can leave it to the half, whatever you prefer. Okay, I'll leave it to the power of half, or you can write a square root. Okay, so a lot of the time, well, we do use chain rule whenever we have exponents that are greater than 1, basically. We can do the chain rule because we can do the power rule of this part and then just differentiate the inside separately. Okay, so let's do another example. So let's do x squared plus 5x. So we're thinking about taking the derivative of something to the power of 8, and then we'll differentiate the inside. Okay, so bring down the exponent, ignore the inside. Then we go 8 minus 1, and then we'll worry about d dx of x squared plus 5x. Okay, so this is 8x squared plus 5x to the power of 7 times 2x plus 5. Now, to simplify this, we can leave it like that, but remember, this can be brought up to the front as well. So if we wanted to, we can just write it as 2x plus 5, x squared plus 5x is 7. You can leave it like it is in the second line, but this is also what it means. So just remember that sometimes you're going to be able to simplify whatever this coefficient is and whatever this is. If you wanted to write as 16x plus 40 times all this, that's also fine. Now let's do this one. So this one, we have to be careful because this is 4x, so we can almost think about this as an f function. And then we have this g function here, 3x plus 5 to the 5. So this is product rule and chain rule. Okay, so to make sure we don't get confused, first let's write out what the product rule is, and then we'll worry about the chain rule part. Okay, so the product rule says that we go d dx of the first function multiplied by the second function, so plus 3x plus 5 all to the 5, plus the derivative of the second function, so 3x plus 5 all to the power 5, times the first. Okay, and now we're going to perform the chain rule on this part here. Okay, so what I'm actually going to do is I'm going to switch these because multiplication, it doesn't matter the order, so it'll just be a little bit cleaner to follow. All right, so the derivative of the first part, so this is 4x, so this just becomes 4. And then this is multiplied by 3x plus 5 to the 5. And we're not going to expand that. Okay, please leave it. And then we have plus 4x. And now what do we have? So the chain rule. So we're going to bring down the 5, and I'm going to put big brackets around all of this, okay? So I'm going to have 5, ignore the inside, and then exponent minus 1. So this is going to be the 4. And then we differentiate the d dx of the inside. Okay, so the 3x plus 5, and then all big brackets. Okay, so this 4x is multiplied by all of this. Now, let's see what we have here. So I have 3x plus 5 all to the power of 5. and then I have plus 4x times 5, 3x plus 5 to the 4, and then this is times just 3. Okay, the derivative of 5 is just a constant. Okay, so that's just 0. And now what we have, these are all being multiplied. This term, this term, this term, and this term. So what we can do is we can multiply this and this together to give us 15. Okay, so we're going to have 3x plus 5 to the 5 plus 4x times 15 times 3x plus 5 all to the 4. And now we can simplify it more by multiplying this term and this term. Okay, so that would be what? 4 times 15, so that's 60x. So 3x plus 5 to the 5 plus 60x times 3x plus 5 to the 4. Now, if I asked you to fully simplify this, what we could do is we have a 3x plus 5 to the 5 and to the 4. So we can factor out 4 from each term. Okay, so we can go 3x plus 5 to the 4. And I could also factor out a 4 from each term. So I could factor out a 4 here. And then we can do 60 divided by 4, that's just 15. Okay, so I guess it wasn't necessary to combine these. But, you know, live and learn. Okay, so the very first term here, the only thing that's left over is one of these factors. 3x plus 5. And then for the second term, this has all been factored out. The 4 has been factored out, and I'm just left with 15x. Okay, so from each term, I factored out a 4, 3x plus 5 to the 4, and then I have 3x plus 15x, so this is 18x left over, and plus 5 left over. Okay, and I can leave it like that. I mean, if you wanted to put the 4 into here, you could, but you don't have to. All right. Let's do another one. Now let's do one where we are doing the quotient rule and chain rule. Okay, so we have a function divided by a function. When we take the derivative of the numerator, we're secretly going to be doing the chain rule. Okay, so let's just first write out what the derivative is. Okay, so for quotient rule, we have the derivative of the top, so d dx of a big bracket 3x plus 2 to the 7, that's what we're taking the derivative of, times the bottom, minus d dx of the bottom times the top. 3x plus 2 all to the 7. And then don't forget, this is all divided by the bottom squared. And don't expand the bottom, just leave it. All right, so now we're going to do the chain rule here. So the chain rule, I'm going to bring down the 7, subtract 1, and then take the derivative of this part. So I'm going to write that out. So 7, 3x plus 2, 7 minus 1 is 6. And I still have to go times d dx of the inside. If you want to directly take the derivative, that's fine. But again, I'm just showing some extra steps. So when you're looking back on this yourself, you know where it's coming from. So that's the whole first term of the top. And then we have minus d dx of x minus 1, so just 1. And then 3x plus 2 all to the 7. And again, this is all divided by x minus 1 all squared. Okay, so now what do I have here? So now I'm going to have 7, 3x plus 2 to the 6. The derivative of this part here, this 3x plus 2, this is just going to be 3. And then times x minus 1 minus, bracket, 3x plus 2, bracket to the 7. And again, all divided by x minus 1 squared. All right, so now this first term, again, all these things are being multiplied together. So I'm going to multiply together the constants, so the 3 and the 7, Okay, and that's going to give me 21. And then I'm also going to bring the x minus 1 up to the front. Okay, I just always seem to write them where the terms with higher power, so this power of 6 here, I usually just write that after these things. Okay, you don't have to. If you wanted to write it as 21, and then this part, and then this part, that's also fine. Then minus 3x plus 2 to the power of 7. And then, again, this is all divided by x minus 1 squared. Now, can we simplify this a little bit? So notice that we have 6 of these terms here and 7 of them here. So how about we take out all 6 from here, and I'll just have 1 left over in the second term. If I factor out my 3x plus 2 to the 6, so then what do I have left over? In the first term, I have 21 x minus 1 here. And then I still have a minus 3x plus 2 left over for my second term. And then again, all divided by x minus 1 squared. And now we can simplify it a tiny bit more. Let me move this. So we have our 3x plus 2 all to the power of 6. And then what do I have? So I have 21x minus 3, so I have 18x. And then I have minus 21 minus 2, so minus 23. And then all divided by x minus 1 squared. Okay, and I can't simplify it anymore. So hopefully that was helpful. Next time we'll talk about derivatives of exponentials and log functions.